Hi everyone, Francis is here. In today's lesson, we'll be discussing compound angles. My aim in this lesson will be to use geometry to derive compound angles identity or compound angles formula. To start, I have drawn a a square or a rectangle whose four angles are 90 degree. Within this four-sided shape, it's a right angle triangle, and that right angle triangle forms a right angle triangle here, forms a right angle triangle here, and here. I'll represent this side of the right angle triangle to be x, and this side to be y. Why the length of this side, why the hypotenuse of this triangle to be 1. So to start this proof or this derivation, the angle x, the condition is that angle x, angle y, and angle x plus y are acute angles, or are all acute angles. Okay, so with that said, if this side of the triangle is x, what will be this? If this side of the angle is x, what will be this side? Recall that the sum of angles in the triangle is 90 degree, is 180 degree. Therefore, here will be 90 minus x. The same thing applies here. Here will be 90 minus y. Angle on a straight line is 180. Here is 90. Here is 90 minus x. Here will be x. And here will be 90 minus x. Okay. What will be what will be the value of this angle? It will be this angle here is vertically opposite to the angle here. So, and vertically opposite angles are equal. Here will be 90 plus x. Okay. With the same thinking, if here is 90 plus x, what will be this length? This angle. It's 90 minus x plus y. Okay. Now with what we have here now, we can use SOHCAHTOA to the SOHCAHTOA we learned in the previous in our previous trig in the beginning of this trig course, or beginning of this trig topic, to fill the length of or the size of the triangle. So with that said, with respect to this angle, opposite over hypotenuse will be opposites over hypotenuse. That's sine. Sine y, it's equal to opposite. What is this? We don't know the length of that. Let's call it k over 1. Therefore, k is equal to sine y. The length of this side, the length of this side will be sine y. Okay. Now, adjacent over hypotenuse. So cos this length, the length here will be cos y. Okay. Now, opposite over hypotenuse, with respect to this angle, opposite over hypotenuse, here will be sine x plus y. And here, this from here to here will be is cos x plus y. Okay. Now, opposite over hypotenuse will give us here to be sine x, sine y. Okay. Y this side of the length will be sine y cos x. Okay. Now, if we do the same thing here, opposite over adjacent. Here would be, I'll work it out here. Opposite over opposite over hypotenuse. We don't know what here. Let's call it Q over sine x. Sorry, no. So sine x, let's call this sine x is equal to Q over cos y. So Q is equal to sine x cos y. This length will be sine x cos y. Okay. Now with the same thinking, this side would be cos x cos y. Okay. So with that, we've been able to fill up, get what the length of the sides, get the values of the length of the side of the triangle, or the length and the value of the length of the square itself. So now take a look from here to here. Sine x plus y, it's equal to sine x cos y plus sine y cos x. So I'll write out here sine x cos y plus sine y cos x. Okay, let me just, so the same thinking applies here. The length of this is cos x cos y is equal to cos x plus y plus this length plus this length. So, but I can also say that cos this length is equal to this length minus this length here. So I'll write that as cos x plus y is equal to, okay, cos x dot cos y plus minus, okay, minus sine y cos x. Okay, so having done this, we've been able to get two identities. Two compound angles formula or two compound angles identity. So what I would want to do, what I would do now would be to say, what if I replace plus y to minus y? What would we have? We'll have it to be x minus sine y is equal to, if I put in sine x, if I put in x here, I will still have the same thing, sine x. If I put in minus y in this cos function, I will still have cos y is still the same thing as cos minus y, because cos is even. So I will still have cos y here. What if I put in minus at the position where I have plus y here? Sine y is even. So I would have minus sine y. If I put in x here where I have cos, replace here with x, cos will not change, it would still be the same thing, cos x. Now let's do the same thing here. I'll replace plus y, I'll replace the plus y to minus y. So cos y, x minus y will be equal to, putting cos here, I would still have cos x. Replace, putting minus y at cos y. Replace this, the plus y to be minus minus y. We'll still have cos y. Now here, replace, we'll have minus, okay? Replace minus plus y to be to minus y here. I would have minus sine y, okay? Then putting x at the replace the x with x here, or positive x here. It will, the cos, it will still have the same thing. We'll still have cos x. So keep in mind that minus would then be plus, okay? So therefore these are our identity. Now I would write these two identities. I'll compress these two identity to be one, and then these two identity to be one. I'll compress them into one particular formula, and I'll compress these two into one particular formula. So if I do that, that will give us our compound angle formula. So I can write those the four formula as sine A plus or minus sine into bracket A plus or minus B will be equals to sine A cos B plus or minus cos A sine B, and our cos will be cos A plus or minus B will be equals to cos A cos B minus plus sine A sine B, okay? So you can see that when we had, I've been able to put this plus and minus together, plus minus together, and the first one gave us plus. That's why we have plus here. And when I had minus, we had minus. I'm having minus here. For cos, when I have cos plus or minus, we would have minus. That's why I'm having minus here. And for the second one, when you have cos x minus y, you have my plus here. That's why I have plus here. So with this said, we've been able to get to identity. Now, what if, let us also put in mind, what if I had, what would a tan A plus or minus B of this function look like? It will be sine A plus or minus B over cos A plus or minus B. Okay. Now I will also write, since this is equal to this, I'll write it as sine A cos B plus or minus cos A sine B over cos A cos B minus plus sine A sine B. Okay, so having said that, we can divide. Let's divide both sides. By cos A cos B. By this, let's divide all the both the numerator and the denominator by cos A, cos B. But to do this, the condition that I'm dividing this cos A, cos B, I'm dividing it keeping in mind that angle A and B, okay, or whatever compound angles I have used here, angle A and B are both positive and they are less than 90 degrees, meaning they are acute angles. Okay, they also, I'm also keeping in mind, or we're also assuming that they are both, the two angles are all in the first quadrant, where they are all positive. So with that said, I can go ahead and divide the numerator sine A cos B divided by cos A cos B plus or minus cos A sine B cos A cos B over cos A cos B over cos A cos B minus plus sine A sine B over cos A cos B. So therefore, this cancel this, okay, this cross this, this cross this, we're left with this, and therefore sine A over this would be tan A tan B, and this will be tan B, this will be tan A. So therefore our answer is tan A plus or minus tan B over 1 minus plus tan A tan B. So these are compound angle formula or compound angle identity. This, and this. The sign of compound angle identity, the cos of compound angle identity, and the tan of compound angle identity. So that's the end of this lesson. I will see you in the next one. Bye for now.